please switch on your mic and speak up. All right.
Okay, sir.
What exactly do you know about the ellipse? Any elliptical shape you have seen in your nearby things? Any place you remember where like ellipse is used?
Sir, shape of egg.
Shape of egg is, yes. Shape of egg, if we see it in the like 2D form, that will be elliptical form. Anything else? Like while it's Earth is moving around the sun, that path is what?
Elliptical orbit.
Elliptical only. Okay. So,
Okay.
how did we get the ellipse? If you remember, this ellipse is a conic, yes or no?
Yes, sir.
This ellipse is a conic. So, and conics are what? They have been like designed by cutting a cone. So, if say this is a cone, if say this is a cone, a right circular cone, if you cut this cone by a plane using this, like this. Alright. So as a cross section, what do you see? You will see this kind of structure. Yes or no? If this plane will be parallel to the base of the cone, you will get a circle. But if this plane is tilted from the base of the cone, you will get an ellipse. Am I clear? Ganesh?
Yes, sir. Clear.
Fine. So, what is ellipse exactly? If you talk for any conic, it is the locus of a point. It is the locus of a point which is moving in such a way, that the ratio of its distance from a fixed point to a fixed line is always constant. Am I clear? So this ellipse is the locus of a point. Yeah, any conic, parabola, ellipse, hyperbola, circle, pair of straight line, any conic, that's the locus of a point which is moving in such a way that the ratio of its distance from a fixed point to a fixed line is always constant. This fixed point is what we call focus. And this fixed line is what we call directrix. These terminologies you have to remember. And is always constant. This constant is what we call eccentricity. This constant is what we call eccentricity. Now let us assume this is a fixed line, L equals to 0. And this is a fixed point, S. Now a point P is moving in such a way that ratio of its distance from a fixed point to a fixed line, PS upon PM, is eccentricity E, this constant. This PS upon PM is E. Now if D is 1, this E is 1, this locus will be a parabola. If this E is less than 1, this locus will be an ellipse. That is what we are doing right now. And if this E is more than 1, this locus will be a hyperbola. Am I clear? Rohit? Rohit, understood? Who is this Rocky Bhai? Rocky Bhai, can you switch on your mic? Arif? So this PS upon PM is E, and this E is what we call eccentricity. For a particular ellipse or hyperbola, this eccentricity will be constant. Yes, for ellipse, it will be less than 1. For hyperbola, it will be more than 1. Shanmugh, understood, Peter?
Yes, sir.
Now, particularly for ellipse, the definition is an ellipse is the locus of a point which moves in a plane that its distance from a fixed point is in a constant ratio to its distance from a fixed line. This fixed point is called focus, and this fixed line is called directrix, and the constant ratio is called eccentricity. Now see, let us assume this is the fixed line. Some Lx plus My plus n equals to 0. Now this is a fixed point A comma B, PS. Now there is a point PH comma K, which is moving in such a way that PS upon PM is E. Am I clear? Now what is PS? PS is distance of point B H comma K from this line. So that is LH plus MK plus N upon under root of L square plus MB square is E times distance of P from means this much into E times is distance of this point P from the focus. That is under root of H minus A square plus K minus B square. Got it? So somehow if you see an equation written in this particular format, if you see any equation which is written in this particular format, that will be the equation of ellipse if this E given in the equation is less than 1. Like I give an example, that is x minus a square plus y minus b square is 1 by 4 times x plus y plus 3 upon root 2 whole square. See it. Now distance of P from the point is x minus a square plus y minus b square. That means a comma b is that point. And this is what distance of P from the line, x plus y plus 3 upon root 2 whole square. Now this is what? This is your eccentricity square, E square. Got it? This is your eccentricity square. Now one simple question if I ask you, that is, like a question if I ask you, it is 169 times x minus 2 square plus y minus 3 square is equals to 3x plus 2y plus 1 whole square. Like this. Now they are asking you, what is the locus of this point? And if it is a conic, what is the eccentricity of this conic? Got it? Now see, this is what? This is x minus 2 square plus y minus 3 square under root. Distance of a point P, x comma y from a point 2 comma 3. It is 169. I took it to the downside. It will be 1 by 13. And this will be 3x plus 2y plus 1 more. Now, to complete this distance formula, I multiply and divide it by root 13. So what do you get? 1 by root 13. It is 3x plus 2y plus 1 upon under root of 13 mod. So this is what PS. This is what PM. That means this is what eccentricity. Had it been more than one, I could have said locus is hyperbola. Now in this particular case, this eccentricity is coming 1 by root 13. So locus is what? Ellipse. Am I clear? Locus is what? Ellipse. So that is why they mentioned it as ellipse in the most general form. Now see, if you simplify this equation, you square, you like solve it somehow, then you get an equation of this type. Yes or no? That is going to be a second degree equation. That is going to be a second degree equation. That is going to be a second degree equation where there will be a term of x square, 2xy, y square, only x, only y, and constant. Now, this is the second degree general equation in two variable. This is what we call second degree general equation in two variable. This is the delta of this equation. ABC plus 2FGH minus AF square minus BG square minus CH square. If this is non-zero and H square is less than AB, then this equation will be the equation of ellipse. This equation will be the equation of ellipse. But for that, ABC plus 2FGH minus AF square minus BG square minus CH square, it should not be 0. Now, this is a determinant form that we'll study in our first lecture of class 12th. First chapter, determinant and matrices. So as of now, you just don't focus on the determinant form. You just only remember this equation that if second degree general equation is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. Then its d will be ABC plus 2fgh minus af square minus bg square minus ch square is 0. Understood? Now, standard equation of ellipse, let's drive it. I will let you know how did I get this. Now, see, this is very particular case. Ellipse is not always like this, what we are trying to draw right now. So as a standard equation, if I take one focus as AE comma 0 and one directrix as x equals to A by E. Definitely, since E is less than 1, so A by E will be greater than AE. All right. Now there is a point P, H comma K, which is moving in such a way that PS upon PM is E. So PS upon PM is E. Now PS is what? Distance of P from AE comma 0. So it is H minus AE whole square plus K square under root is E times. Now see what is PM. PM is this total distance. Now this is H and this distance is A by E. So what is PM? PM is A upon E minus H mod. Got it? So it is mod of A minus EH. Fine. Now square both sides. So you get H square plus A square E square minus 2AEH plus K square is A square plus E square H square minus 2AEH. So this 2AEH cancel. So it is 1 minus e square into h square plus k square is a square into 1 minus e square. Got it? So locus will be x square upon a square, y square upon a square into 1 minus e square equals to 1. Understood? This is the standard equation of ellipse, and this a square into 1 minus e square is being expressed as b square. So from this we get the formula for eccentricity as 1 minus b square upon a square. This is the eccentricity of the ellipse. So that's x square by a square plus y square into a square into 1 minus e square is 1. Correct? Now, if you realize this is a second degree question in x as well as in y, and if I replace x by minus x, the equation does not change. So that means replacing x by minus x, if equation does not change, that means this equation or the graph of this equation will be symmetric about the y-axis. Similarly, replacing y by minus y, if the equation does not change, that means equation of that curve will be symmetric about the x-axis. All right. Now, if it is symmetric about y-axis, that means if one focus is AE and one directrix is x equals to a by e, that means there will definitely be another focus that is minus AE comma 0 and another directrix that is x equals to minus a upon e. So every ellipse, it is always symmetric about something. So every ellipse is having two focus and two directrix. Am I clear? Every ellipse is having two focus and two directrix. Now let us see something about the ellipse. Let the equation of ellipse be x square upon a square plus y square upon b square equals to 1, and a is more than b. A is more than b. See, this graph has been designed using so many parameters, specially used in calculus. So don't get confused, where did it come from? Once you get to know about the increasing decreasing behavior of a function and the other horizontal tangent, vertical tangent, point of symmetry. So once you get to know about this, you will get to know about this equation thoroughly on your own. Fine. So vertex of an ellipse. Now vertex are what? Vertex are points where ellipse intersect with the line joining focus. So this is the line joining focus. Now here at A and A dash, this ellipse is intersecting with the x-axis. So vertex is what? The point at which ellipse cut the x-axis or axis of the ellipse, I should say. So this is a comma 0 and minus a comma 0 are called the vertices of the ellipse. This b or minus b, they are not called the vertices. Vertices are the line joining foci. Wherever this line is intersecting the conic are called the vertices. So vertex is sorted simple. Now major and minor axis. Now distance between the two vertices is called major axis or length of major axis. Like here, AA dash will be a major axis. AA dash is major axis. So the line, the axis at which focus are lying is called major axis. Similarly, BB dash, this AA dash can be written in capital. So this AA dash is called major axis and this BB dash is called minor axis. The formula of eccentricity that I just told you, that is 1 minus b square by a square. It is not always like this. It is basically under root of 1 minus minor axis upon major axis whole square it is. So don't ever confuse with that it has to be y in the b in the numerator, a in the denominator. It should be basically 1 minus minor upon major. Got it? So length of major axis will be 2a and length of minor axis will be 2b respectively. Got it? Now center. Midpoint of the foci is called center. The point which bisect each other, which bisect each chord of the ellipse is called center of the ellipse 0, 0. The point which bisect each chord of the ellipse is called center 0, 0. This is basically 0, 0 is the point if there is any chord passing through that point. 0, 0 is the point at which if any chord passes through it, that chord will get bisected by that point. That chord will get bisected by that point. Now next, 2m, zm and z dash n are two directrix and the equation x equals to plus minus a by e and x equals to minus a by e are the equation of directrix. Fine. Now ae comma 0 minus ae comma 0 are the two foci of the ellipse. Latus rectum is the chord which passes through entire focus and perpendicular to the major axis is called latus rectum. Chord which passes through either focus. See, this is the ellipse. Now, there is a chord. Say this is the focus AE comma 0. There is a chord which is perpendicular to the axis and passing through the focus. This is what we call latus rectum. Same as it was in parabola, latus rectum. And ends of latus rectum is AE comma B square by AE comma minus B square by A. So length of latus rectum will be 2B square upon A. Am I clear? Shanmugh understood? Ganesh? Shanmugh? Inderjeet? Anyways, sure. Let's go. So length of latus rectum, I just told you, it is 2B square upon A. And that is it. Just remember this formula also for the eccentricity. Got it? Now say there is a question, simple question. Length of latus rectum is 1/4 of the length of minor axis. Find the eccentricity of the ellipse. Find eccentricity of the ellipse. Now see, very simple question it is. Length of latus rectum. Now what is length of latus rectum? Length of latus rectum is 2B square upon A is equals to 1/4 of the length of the minor axis. That means 1/4 and length of minor axis goes to B. Now 1B cancel. So B upon A you got as 1/4. Now if B by A is 1/4, eccentricity is under root of 1 minus B square by A square. So 1 minus 1/16. That is under root of 15/4. Am I clear? Now, sometimes we do see this kind of ellipse. I can say here, what is the specialty? Y-axis is the major axis. X-axis is the minus axis. Focus lying on the Y-axis. So if the ellipse is like x square by A square, plus y square by b square equals to 1 and b is greater than a. B is greater than a. Got it? So if b is greater than a, it will be an erected ellipse. Focus will lie on the y-axis, I repeat, 0, comma, plus minus be. Directrix will be y equals to b by e or y equals to minus b by e. Fine. Now, very important, focal distance. The focal distance of a point P x comma y on the ellipse this are called what? Focal distance. And this is very good. See, there is an ellipse that you have. Now, this is my x-axis. This is my y-axis. This is one focus, AE comma 0. This is one directrix, x equals to a by e. This is another focus, minus AE comma 0. This is another directrix, x equals to minus a upon e. Now say there is a point P, h comma k. There is a point P, h comma k. Now if it is S1, this is S2. PS1 is what? PS1 is E times this distance. Got it? So PS1 is E times PM1. And now this is E times, what is PM1? PM1 is A upon E minus H. So it is A minus EH. This is the focal distance with respect to S1 for the point P. Now PS2 is what? E times PM2. Now what is PM2? Got it? PS2 is E times PM2. Say this point is M2. Now, this is what? A upon E and this is H. So it is H plus A upon E. So A plus EH. And now if you see the most important property, PS1 plus PS2 is equals to 2A. Sum of the focal distances of a given point on the ellipse is always equal to the major axis. Understood? So PS1 plus PS2 is 2A. Now let's do a question of this type. Find the center length of the axis, means major axis, minor axis, eccentricity, focus of the ellipse. Now, first of all, we will shift this ellipse. You remember parabola question, we have done old parabola, new parabola. Same type, old ellipse, new ellipse. So it is 12x square plus 24x plus 4y square minus 16y plus 25 equals to 0. Now from this and this take 12 common. You get x square plus 2x. From this and this take 4 common. It is y square plus 4y and plus 25 equals to 0. Yes or no? Now here I add 1, subtract 1. Here in this bracket, I add 4, subtract 4. So it is 12 times x plus 1 whole square minus 12. 4 times y plus 2 whole square minus 4, 4 the 16, plus 25 equals to 0. So it will become x plus 1 whole square 12 times. 4 times y plus 2 whole square is equals to 16 and 25, 41. 16 and 25. Y square plus 4y plus 4 minus 16. So 25 minus 16 minus 12. Minus 12 minus 16 and plus 25. So 16 plus 12, 28 minus, so it will be 3. Am I clear? So it will be x plus 1 whole square divided by 1 by 4. Y plus 2 whole square divided by 3 by 4 equals to 1. This is your equation of ellipse. Now what we do, that was same concept, new one and old one. Now how's this new one came from? You just replace x plus 1 by capital X and y plus 2 by capital Y. Correct? So it will become capital X square upon 1 by 4 plus capital Y square upon 3 by 4 equals to 1. Now see, for the new ellipse, center will be what? 0, 0 means capital X 0 and capital Y 0. So for the old ellipse, if you put capital X 0, small x minus 1. If you put capital Y 0, small y minus 2. Correct? Have a look. Indrajit. Now, eccentricity will be under root of 1 minus. Now, b square upon a square, and here you realize this b is greater than 1. Yes or no? This will be this kind of ellipse. B is greater than A. So eccentricity will be under root of minor upon major. Now minor will be 1 by 4, major will be 3 by 4. 4 cancel. It will be under root 2 upon 3. Under root 2 upon under root of 3. Understood? Now focus will be what? 0, comma plus minus BE. Now 0 is sorted. B is what? B is under root of 3 by 2 and E is what? Root 2 upon root 3. So root 3 cancel. B by E. B is root 3 by 2 or by E means under root 3 upon under root 2. No, sorry. Focus is B into E. So B is under root 3 by 2 and A will be root 2 upon root 3. Root 3 cancel. So focus will be 1 upon root 2, 0, comma 1 by root 2. Now you just place that, get the focus for the old ellipse. Got it? We have done multiple questions in parabola also for this variety. Now, see another question. Find the equation of the ellipse whose foci are 2, 3, minus 2, 3 and semi-minor axis is of length root 5. See, first of all, if these are the foci, one is minus 2, comma 3, other is 2, comma 3. So midpoint will be the center of the ellipse. So the center is going to be 0, comma 3. So if center is 0, comma 3, this ellipse will be something like x square upon something. Y minus 3 whole square upon something is equals to 1. Now you just need to find the denominators of x square and y square. Means we just need to find the values of a and b. Now see, they are saying semi-minor axis is of length root 5. Means b is root 5. So b square is what? 5. So this came 5. Correct? Now, distance between the two foci is 2AE. 2AE is 4. So AE is 2. So A square E square is 4. Now A square E square is A square minus B square is 4. B square you already have 5. So A square is going to be 5 plus 4, that is 9. Very beautiful question. So you just put it 9. This is going to be your correct answer. Am I correct? Now, from this, you remember here we have done focal distance property of the ellipse. There is a point whose distance from one focus will be a minus EH, whose distance from another focus will be a plus EH, and the sum of these two distances PS1 plus PS2 is 2a is constant. 2a is constant for a given ellipse. So the same thing is given here. PS1 plus PS2 is E times PM plus PN. So that will be 2a. In other words, see, this is also a very important definition. In other words, an ellipse is a locus of a point which moves in a plane so that the sum of its distance from fixed points is always constant. PS1 plus PS2 is equals to 2a. So locus of a point which is moving in such a way that the sum of its distances from two fixed points is always constant. This constant distance should be is constant to a, it should be more than the distance between fixed points. This constant 2a, it should be more than the distance between fixed points. And definitely, for an ellipse, this PS1 plus PS2, this S1, S2 will be what? Foci. Distance between the foci comes what? 2AE. And definitely this 2AE, it is less than 2a. Got it? Hence, an ellipse is also defined as a locus of a point P which moves so that the sum of its distance from two fixed points is always constant. Fair enough? Any doubt, anybody? Any doubt? Yes. Got it? Now, let's do a very good question that was once came in IIT also. See, there are two ellipses. One lies inside the other one. This is one ellipse. This is another ellipse. Its center is this one. Its center is this one. So, two given ellipse with centers as S1 and S2. Say this is S1, this is S2. So when they mention two given ellipse means radius, they are also known. Got it? Let us assume radius as R1 and R2 as their radii. So two given ellipse with centers S1, S2, R1, R2 as their radii are such that one lies completely inside the other one and non-concentric. And non-concentric. And non-concentric. Now another circle, another moving circle is touching both of them. Find the locus of its center. Locus of its center. That means now there is another circle like this. And the circle is touching both of them like this. So definitely this green circle you see, its radius is also increasing or decreasing. It is touching both the circles. Now let us assume its center is here C with radius as R. So what is CS1? CS1 is what? R1 minus R. What is CS2? CS2 is what? R2 plus R. If you do it, add both of them, CS1 plus CS2 is R1 plus R2. Yes or no? Now listen to me very carefully. That means there is a point C. Forget the circle now. There is a point C which is moving in such a way that sum of its distances from two fixed points S1 and S2 is always constant. There is a point C which is moving in such a way that sum of its distances from two fixed points S1 and S2 is always constant. And definitely this is always constant. This constant, that is R1 plus R2, is more than the distance between R1 and R2. Sorry, S1, S2. Because you realize distance between S1 and S2 is even less than R1 minus R2. But CS1 plus CS2 in my case is coming R1 plus R2. So locus will be what? Locus will be ellipse. Am I correct? Locus will be ellipse. Focus will be S1 and S2. And length of major axis? Major axis will be what? R1 plus R2. Got it? So this is a focal distance property of the ellipse using which this beautiful question has been asked in JEE twice. Fine. Now in our next session, we will do parametric question of the ellipse, and we will also cover this auxiliary circle and then position of points with respect to an ellipse, and then we will move to tangent. All right. So that would be all from my side for today. Now, just before leaving, just leave a feedback about the session. Then we will be free to leave.